So hello everybody. Don't worry, you will not that much scientific language. I'm trying to keep it simple. Let me share also the personal experience with Halina visiting our facility. She wrote me like, I would like to see a bit something about your facility. Would you have 15 minutes? And I was like, yes, I would have 15 minutes, but be sure it will be longer. Then we spent lovely 1.5 hours together, I believe, in which I just went briefly through what we are offering. So this is roughly to tell you that within the next 20 minutes, I will tell you really briefly what we are offering. And if you will not understand it, I'm sorry, but you can always come back. So as I said, roughly 20 minutes, quite some slides, briefly what we are offering, what happened over last year, and what we plan for next year. Probably most of you know, but just to remind you, since the January this year, we merged the former facility focused on X-ray diffraction and BioSAX. So for various reasons, it makes sense to combine us together. That's why we are now biomolecular directions and crystallography. And basically those machines that were there were split. So the diffractometer for small molecules went to Institute of Chemistry, and they are working on them there, while the one for the biomolecules, for big molecules that we are dealing with, and the BioSAX is now under our wings. So it nicely fits our portfolio, and you can contact us now under one brand. So at the moment, you can meet up to 10 people somehow connected to biomolecular direction and crystallography facility. There were several changes over last year. One important is that Misha Vimrova was nominated as the deputy head. So if you can not reach me for something very important matter, you can still contact her. It's really harder to reach her anyway, but you can. If you miss Itka, that was member of our facility and then left to raise two boys from the very small age to currently being independent rockets of their own, she's back over the last few months, and she will hopefully stay with us for much longer now. And at the same time, Monika Kubichkova has some health issues, so she's currently on long-term absence. So we are somehow moving here and there, but still there is quite some people that you might know who will be there to help you. What we are offering is roughly 16 different techniques with 30 instruments operating. Some of them are obviously overlapping, some of them are very unique. So you can imagine it's quite complex, and we are mainly focusing on biomolecules. So how to describe them, how to characterize them, how to see their interactions. And as I mentioned, we are also having a big portion of our resources dedicated to the X-ray diffraction and crystallization. So to give you some overview, for biophysical characterization, that would be actually also quite a good name for our facility, in fact. You can come if you're interested in your molecules, no matter if it's protein or nucleic acid or whatever it is, and you want to know if it's homogeneous, so if you have your sample well homogeneous, if it's stable due to some external environment change like pH, but mostly temperature, or if they are folded, mainly in terms of proteins, but also in terms of nucleic acids. So for this, there are several techniques. They can be sometimes combined, sometimes complementary, sometimes unique enough. For the interactions, obviously, life is about interactions. So you might want to know whether your molecule of interest is interacting with something else. And I really mean by something, any other type of molecules. So we can work in solution, we can work on surface. You might know that a lot of interactions take place on the surface of cells, so it makes sense to study stuff on surface, and probably 100 people can tell you how they also measure stuff on surface. We have also something for the cell-based techniques, so also this can be implemented. And we can touch different type of parameters. So we can see how strong it binds, about the affinity, but also about the thermodynamics or kinetics. So it's especially important if you want to go deeper into understanding the mechanisms behind, or for example, when you are interested in development of drugs or some inhibitors or something like that. As I said, we are not just working with proteins, even though this is the major focus of ours. So you can come with virtually anything that's small enough to be analyzed. Since we merged with the X-ray crystallography facility, now we are offering the full portfolio or full pipeline of the crystallography experiments. So we can start with the first screening on the crystallization, go through the optimization, test the diffraction, collect the data, solve the structure. This everything can be done within our facility. So if for whatever reason you are not going yet for NMR or cryo-EM, because eventually we'll end up there anyway, you can still come to us and try to crystallize your protein and analyze structure the old-fashioned way, but still pretty useful. Since we are dealing with quite some, let's call it state-of-the-art machines, they are frequently automatized or high throughput in some way. And I would like to highlight this because it's not that you come frequently and you spend 1 week in our facility to try to analyze your single sample, but you can also do a lot of high throughput tests, meaning you can screen your libraries of small molecules, you can screen various mutants, you can go for anything of this kind. And in fact, since we are having also the pipetting robotics, you can also come just use the pipette. Let's imagine that you want to aliquot your 60 plates for whatever experiment you are doing, and you don't have high throughput robotics in your lab or in your facility. You can still come and you can do that within 1 hour for you, instead of you spending a lot of manpower on doing that manually. So this is also very simple, and the machines are there. If you want to use anything like that, just contact me and we'll find a way how to do that for you. Regarding equipment, we didn't install anything new this year, but there are some things that were installed relatively later last year in 2022. So I'm happy that we managed to put our new analytical ultracentrifuge in operation. Just to highlight this, there are just 2 places in Czech Republic where you can really measure analytical ultracentrifugation. Then that's what Halina mentioned. Yeah, this nice, molecules on centrifuge enjoying the high field. It's perfect because you can analyze them directly in solution with no labeling, no interference from outside, just they feel a bit heavier. But we are having now the new centrifuge and new rotor, meaning we increase the throughputs roughly by 2-fold from the old 3-position rotor to new 7-position rotor, so it's perfect to be used. Another technique that focuses on the homogeneity and interaction of molecules is the statistical chromatography. You might know it from your preparations, but we have the analytical version with multiple detectors, being able to distinguish various types of molecules, separate them on various ways. So we purchased some new columns so to make this separation easier. Another relatively newcomer, we recently acquired a cell sorter. So there is already a user that is basically coming from the NMR focus group, and they use this sorter to separate cells that are containing their protein of interest, so to be used on in-cell NMR. So this is a nice example how we can nicely collaborate with other facilities around. So if for any reason you think, maybe I would like to sort my cells in solution before I do anything else, AFM, whatever, NMR, other stuff, maybe this would be of interest for you. And we also recently finally managed to make our microdeposition system really fully operational and running. That means you can now think on making your customized biosensor arrays or really pipette the very tiny volumes. This is really not a typo, it's really picoliter, so less than nanoliter of volume per droplet. So I don't believe we can go much below that unless we focus on single molecule devices. There are also several changes in terms of the personal assignment. So as we are developing, acquiring new machines and merging with other facilities, from recently on, Tomáš Klumpler is now the person focused on the dynamic light scattering. So if you want to be trained on using DLS, you will probably no longer meet me, sorry for that, but you will meet Tomáš, and he's more than capable of training you to operate. Also, when Jitka came, she returned back to her beloved isothermal titration colorimetry duties, so you can be trained there by her. And Honza Komar is currently temporarily, as I said, because Monica is not there now, responsible for our AUC. Also, we are trying to broaden our knowledge. Obviously, we are roughly 8 people in the lab, but having 30 machines is a bit complicated. So we are trying to be more, let's say, sustainable in if somebody is missing, somebody else can help you. So it might happen easily that if you are coming for a specific technique, not only the main responsible person will be dealing with you, but maybe also some substitute who is capable of operating that. So just not to be surprised that you will not meet your beloved person for whom you are using the facility. Bit of statistics. We had really nice full use year last year. This year seems to be much worse. Basically, I would say the main reason is the AUC. As I said, we doubled the capacity of our centrifuge, meaning we halve the time needed for measuring. And basically, the drop is mostly driven by this. But we are happy to have still roughly 90 users per year, which I think is quite reasonable to operate a facility like that. And no surprise, it's still the same trend that whichever machine we offer as a service is usually much more used than the one that we force users to use themselves. I don't know why is that, but maybe I interpret this we are offering good service. Could be other reasons. Anyway, this results in some publication. I'm really glad to see that people are using our facility, writing papers, and acknowledging. Yeah, you hear it for the 5th time this day, sorry, but it's really important. So we have several quite nice papers also in nice journals like Nature Communications or NAR. So I think that it's really nice what people are doing in our facility. Yeah, you see it, you know it. Let's go further. In year 2023, we also organized several workshops. Usually we organize like 2 to 3 workshops per year. This year was really full, having like 8 different workshops focused on various techniques, various biophysical techniques, instruments, and so on. Of course, everybody is invited to come and join our workshops. There will be definitely some more next year. Few reminders, I would like to remind users, if there are any among in the audience or online, even if we are offering some full service, you can be still trained to know how to process the data yourself. It's not only beneficial for us that we spare our manpower on processing your data, but you also will understand them much more than if you just receive the final report. So it might be really beneficial, and especially if you then want, for example, your publication figures is really good if you can process them yourself because you are the one who know what you want. Instead of asking us to prepare picture, well, you can really do it yourself. The data evaluation computer is available. We can help you with anything like that. For those who are not users yet, I would just wanted to remind that there are various ways how to access. Obviously, the main one is via CISB projects, but there are other ways, especially for the foreigners, and you might end up even in using our facility for free. What do we want for the next year? So again, as it was mentioned, there was a big proposal for renewal or new installations, which we do not know yet if we will get the money, but we all hope for it. So if that happens, we definitely plan to install mass photometer, which will be really great technique, and we just had a workshop on that recently, that can determine what is the size of the molecules in solution, but at very low concentrations. What does it mean? Just an example, if you want to go for cryo-EM to study your complex, you can check that at small concentration, your complex is still intact and well formed. Because if you have low affinity parts of that complex, they may just fall off once you dilute the sample. So here it should be possible to test it. It can also nicely complement those cases when you have really low amount of sample, but you want to analyze it anyway. And there are people who are dealing with that. Also, we want to have a fraction collector for the SEC-MALS machine, again, like for subsequent use, for example, for mass spec or eventually cryo. And we want to acquire the fluorimeter for instance, anisotropy measurement, which is not being present in our facility so far. And this is something that you're frequently reminded of, something we should have. We also plan to make some workshop in 2024. There will be definitely methods for characterization of biomolecular interactions 1-week course. It's part of a course for university, but we keep the lectures open for everybody. So if you're interested in more details about techniques, you can definitely come. And annually, Tomasz, who is dealing with our BioSAX, in collaboration with people from Prague, is organizing BioSAX course. Last year was here, next year will be in Prague, but again, it's shared organization by us and by BioSAX. And I hope there will be something more. So probably the last slide. What shall happen in 2024? We hope for new installments, but we will see based on the money. We want to modify our booking system in a bit so that we will more reflect first what is the real services we are offering, including the data analysis and so on. And there might be some adjustment for the prices. We don't want to increase on purpose, but we want to more, let's say, level the prices so that really they would correspond in what was being used. And yeah, what is important, as was mentioned already by other facilities, for next year, the contribution of CISB will lower from 90 to 85%, means as users, you will need to pay 15% of the real prices. It's still not much, but there will be increase due to that. And we are currently negotiating about implementing more machines that are throughout campus into our booking system so that if you would like to use something that is not part of SATEC, not part of BIC, but still it somehow belongs to biophysics, it might be just one place where you would go, where you would book your machines, and maybe you will have also access to something we cannot acquire other way. So I hope that this will go well, and we will manage to broaden, let's say, our portfolio also this way, and maybe once in the future really centralize all the resources on the campus under one umbrella of ideally SATEC or a business. Obviously, if you have any recommendation, and there will not be much time for discussion, maybe 2 minutes, feel free to come, tell me what you want, what you are missing, what is your idea. I'm completely open to discussion with anybody, and I'm really glad if you are interested in the future of our facility and your research. So that's it from my side, and thank you for your attention.
There are really exactly 2 minutes for one short question.
So your micro dispensing system, what would be the resolution in X and Y, and could it be used, for instance, for lithography as well?
I cannot say if it will be used for, if it can be used for lithography. I never thought of that, but maybe we can figure out. The resolution, I believe, should be something like 10 microns. But of course, it depends on the specific capillary and specific setup. I would not guarantee, well, that's what the producer guarantees, but I would probably a bit more on safe side, so probably